Welcome back. We're starting chapter 9 today, and we're going to begin with an introduction to polynomials, giving us a little bit of vocabulary to use in this chapter. So when we talk about a monomial, we're talking about a polynomial with only one term. Now the terms are the things we add. So a monomial could be something like 5. It could be something like a 3x or a negative 2x cubed. Those are all monomials. They have one term. Now, a polynomial has many terms. So we might see a binomial. And a binomial has two terms, like a 3x plus 5 or a 2x squared minus 7. Those are binomials. There's two terms. And a trinomial has three terms. So something like 2x cubed plus 5x minus 6. That's a trinomial. There's three terms. Anything above a trinomial, we just call it a polynomial generically. Now, when we talk about a polynomial in standard form, they're written in this form. Now, don't be afraid by this notation. All it's saying is it's going from the largest exponent, the largest degree, to the smallest exponent. So it goes something like x squared to x to the constant. Now, when we talk about a sub n, that's just our leading coefficient. N is the degree. That's the largest exponent. And then we talk about the constant term, a sub 0. That's the number without a variable. So here's some different types of polynomials and functions. These are going to be names of the polynomials based on their degree. When we have degree 0, we call that a constant polynomial. And a constant polynomial, for example, f of x equals 5. There's no variable. Degree of 1, that's linear. Linear, degree of 1, it's to the first power. So it might be something like negative 3x plus 5. Degree of 2, we call that a quadratic. F of x equals, now our largest exponent's 2, 2x squared plus 6x minus 7. Degree of 3 is a cubic polynomial. The largest exponent is 4. Negative 6x cubed plus 5. Degree of 4, we call that a quartic. Think about 4 quarters in a game, or 4 quarters in a dollar. So for example, f of x equals 3x to the 4th plus 2x cubed minus 7x plus 5. And then for degree of 5, we call that pentic. Think about the pentagon with 5 sides. F of x equals 5x to the 5th plus 6x. Now, all of these polynomials I gave you are in standard form. They go from the largest exponent to the smallest exponent, to the constant, if that exists. Next, we're going to be talking about, are these functions? And if so, we're going to write them in standard form, list the degree, the type, and the leading coefficient. So what we're looking for here is we're making sure that all of our exponents for the variables are whole numbers and that they all are positive. So for number 1, because of that 1/2 power, it is not a function. Not a function. And that's because of that x to the 1/2. So we're not going to answer the other parts. Now, number 2. The square root of 10 is okay. That's just a constant. So this one, all of the exponents are positive and whole numbers. So yes, it's a function. Now, to write it in standard form, g of x equals largest exponent to the smallest. Negative 8x to the 5th plus x to the 4th minus 4x squared, and then the constant plus the square root of 10. Now for this, the degree, the largest exponent is 5, and we call that pentic. And the leading coefficient, I'm just going to put LC for short, is negative 8. For number 3, all of the exponents are positive whole numbers, so it is a function. So in standard form, f of x equals x cubed minus 4/5 x squared minus 1. That goes from largest exponent to the smallest. So the degree is 3, and we call that cubic. And our leading coefficient is a positive 1. Number 4, if we look, we see that negative second power. That's no good. It's not a function. Let's go to the next page and see some operations that involve involve polynomials. So if we're looking at problem number 1 on this page, what we're going to do is we're going to get rid of the grouping symbols and combine our like terms. So we have our 2x squared minus 5x plus 1. And distribute the 1, you get plus x squared minus x minus 4. And now we just combine our like terms. So to combine the like terms, 2x squared plus x squared is a positive 3x squared. Negative 5x plus negative x is negative 6x. And 1 plus negative 4 is a negative 3. There is our new polynomial, and it's written in standard form. Problem number 2. Distribute the 1 for the first one, so nothing happens. 5y to the 4th minus 2y cubed plus 9. But now there's that negative there, so we want to distribute the negative. Negative 1 times negative 2y to the 4th is positive 2y to the 4th. Negative 1 times 8y squared is it's minus 8y squared. Negative 1 times negative y is plus y. Negative 1 times 2 is negative 2. Now we combine our like terms. We have the 5y to the 4th and the 2y to the 4th, so 7y to the 4th. We have a negative 2y cubed. We have a negative 8y squared. We have a positive y, and 9 plus negative 2 is plus 7. We're going to skip down now to problem number 5. So for number 5, we want to distribute first. So we're going to distribute the 2. So negative 2x squared plus 4x minus 8. And now we distribute the negative 3. So minus 6x squared plus 3x. Combine your like terms. The negative 2x squared and the negative 6x squared is negative 8x squared. The 4x and 3x is plus 7x. And then the minus 8. Good. Number 6 now. Be careful with number 6. One of the ways you can do this is by writing it out. X minus 5 times x minus 5. So we're going to multiply the binomials. X squared minus 5x minus 5x plus 25. X squared minus 10x plus 25 is what we get when we multiply those. We're going to skip to problem number 9 now, please. So for number 9, we're going to multiply. So we're going to distribute the x and the 5 to the trinomial. X times 2x squared is 2x cubed. X times negative x is negative x squared. X times negative 7 is negative 7x. Distribute the 5. So plus 10x squared minus 5x minus 35. Now we combine our like terms. We get the 2x cubed. Negative x squared plus 10x squared is plus 9x squared. Negative 7x and negative 5x is negative 12x. And then minus 35. And there is our new polynomial. Let's go to problem number 11 now. Now for number 11, it's x minus 3 cubed. So what that is that's x minus 3, x minus 3, and x minus 3 again. When multiplying more than two numbers, multiply two of the binomials and then multiply that answer by the third. So I'm going to multiply 2 the x minus 3. So it's going to be, for these two, x squared minus 3x plus 9 times x minus 3. Always combine first. X squared minus 6x plus 9 times x minus 3. And now we're going to distribute the x and the negative 3. It doesn't matter that's on the other side. X times x squared is x cubed. X times negative 6x is negative 6x squared plus 9x. Distribute the negative 3x squared. Negative 3 times negative 6x is plus 18x. Negative 3 times 9 is negative 27. So you combine, you get x cubed minus 9x squared plus 27x minus 27. And let's just do one more. Let's do problem number 13. It doesn't matter which you multiply first. Just multiply two of them and that answer by the third. I'm going to multiply the first two. So I'm going to get a 2x squared minus 8x plus 3x minus 12 times x plus 2. So I'm going to combine my like terms before I multiply again. So I get 2x squared minus 5x minus 12 times x plus 2. Distribute the x and the 2, I get 2x to the third minus 5x squared minus 12x plus 4x squared minus 10x minus 24. And then when we combine, 2x cubed minus x squared minus 22x minus 24. And there is our polynomial. Please complete the rest of these as your assignment, and the key will be posted on campus. Thank you, and I'll see you in the next video.